Good evening, one and all present here. So today we'll be moving towards the new topic. So in today's class, we will be discussing about some more sensors and its application, and that too we'll try to practically implement and see. Okay, we'll see how practically you can do it. Okay, so we'll be again using that tool, Tinkercad tool. On that tool, we'll try to show you how you can implement it. And suppose in future, if you are purchasing those sensors and all, you can do it yourself also. Okay. So let's try to understand those sensors and the related projects and the related applications as well. Okay. So today we are going to discuss about two different kinds of sensors and their related applications. So one of them is called as temperature sensor and other is called as moisture sensor. Okay, so we will see in detail that how your temperature sensor looks like and how you can implement, how you can connect it with the Arduino board. Okay, and we will also see that how your moisture sensor looks like. Actually, there are many variation in the moisture sensor. Okay, we'll see all those variations and we'll see the practical areas where we can implement it. Okay, so let's try to understand these two sensors in detail, and let's also try to implement it. Let's also try to understand the pin diagram of these sensors, as well as we'll also try to understand the applications of the sensors. Okay, so let's get started, guys. So as I told you, we'll see first of all the moisture sensor. So this moisture sensor actually comes under many variations. So one of them is called as soil moisture sensor. Okay. Now from the name only you can understand what is the meaning of soil moisture sensor. Means a sensor which will go deep inside the soil and can tell what is the moisture content inside the soil. Okay. So you can understand when you plant a tree, like suppose if this is tree, you know that the root of the tree goes inside the soil, and this is your tree, suppose. Then this sensor can tell a lot of things. Okay, it will tell you about the moisture content, means whether how much water is required by this tree that we can finalize. Okay, and then we can decide and we can give that much water every day. Okay, for example, suppose this is a human being, and suppose this human being drinks 2 liters of water every day. Okay, so based on that we can decide that how much water this person will require for a month. Yes or no? And based on that, a lot of predictions can be done. Okay, for this person, this much water if you keep, then he can survive for this many years. Yes or no? Similarly, if you can implement this moisture sensor inside the soil, we can find out that how much moisture content is present today. After some hours, we can also find out again how much moisture content is present. Based on that, we can finalize when we should give the water to the soil and when we should not give the water to the soil. Okay, generally what happens sometimes, if it is raining, suppose if there is a rain, then when it rains, you know that water falls on the ground. But if suppose the rain is less, then it becomes very difficult for us to decide whether we should irrigate the land or not. Okay, we may feel that okay, there was rain, so there is water content available in the soil, so no need to irrigate. But maybe if suppose the rain was very less and only the surface was wet and inside the water has not reached and there is scarcity of water inside the soil, so and if you are not irrigating, then the plant will not be having sufficient water. Okay, so in those all scenarios, this water or you can say soil moisture sensor plays a very vital role. Okay, so nowadays what happens, these soil moisture sensors are used by the farmers. Okay, I'll also show you some pictures where I'll make you understand regarding this. Okay, so on the left hand side you can see I have shown you two sensors, and on the right hand side also I have shown you two sensors. Okay, so if you are going for an academic level project, then you have to switch to these right side sensors. Okay, so generally if you try to do a soil moisture sensor based project, generally in the colleges and all, generally students will be using this sensor. Okay, it is the cheapest one and it is readily available on Amazon, Flipkart and all. You can easily get also. Okay, this is bit costlier. So generally students move to this sensor. Okay, but when you want to implement practically in the farm, in the farm areas where the plants are actually planted, then in that case we will have to go and look for more sensitive sensors. Okay, so these two sensors are very sensitive ones and they give very accurate results. Okay, so generally if you are using the sensors in the practical environment where your productivity will matter a lot, in that case we'll go for the costlier sensors which is shown in the left hand side. Okay, so what these sensors will do, they will tell you what is the moisture content of the soil. Okay, means how much moisture is present inside the soil, and based on that you can irrigate the land. Okay, and when you irrigate the land, it will give you the real time value whether that how much, what is the moisture content, whether the moisture content has increased or not. That all values it will keep on giving you, and you can decide yourself when you should switch off the irrigation. Okay, so in that way you can safeguard also a lot of water also, because when we irrigate the land, generally we don't know that when the moisture content is more than enough. Okay, what we do is we just guess and irrigate the land. Yes or no? We will guess and okay, fine, let's irrigate the land for next 1 hour. So for 1 hour the water will be going on the land, it will be filling the land, and suppose if only in half hour the moisture content has become 100%, then the next half an hour, what happens, you are wasting your time, you are wasting water, you are wasting I mean petrol, diesel and all also. Yes or no? So many wastage is there. So this soil moisture sensor plays a very vital role. Okay, so I hope you have got my point. Now the point is that these sensors are generally analog in nature. Okay, they are what? Analog in nature. So you know that if a sensor is analog in nature, it will generate the value ranging from 0 to 1023. If you remember, I have taught you a topic called ADC. If you remember, analog to digital converter. Yes or no? So generally these sensors, they will generate ADC values which will be ranging from 0 to 1023. Okay, so once you dip it inside the soil, you may get value, let's suppose 100, or you may get value like 1000. You can get any analog value, and that all analog value will be ranging from 0 to 1023, and based on that you can decide whatever you want to do. Okay, like suppose if you say 0 means there is no water. Okay, and 1023 means sufficient water, then if suppose I'm getting value as 100, then you can understand what is the case. The case is that there is very less water, and in that case what you should do, you should switch on the irrigation pump and the water should keep on flowing, and you will observe that now the value of ADC from 100 it is moving towards 1000. Okay, and suppose if it has reached 1000, then you can say there is sufficient water and you can switch off the motor. Okay, and by that you are safeguarding, or you can say you are saving lot of water. Okay, getting my point, guys? So this analog value which is ranging from 0 to 1023 will tell you the complete story, and based on that you can write program and you can control the flow of water, and you can do lot of things. Okay, so I hope you guys have understood what is soil moisture sensor, where it is used, what is the advantage of it, and how we can program it. Okay, so how we can program it, we'll just do it after some time. Rest of the things I hope you have understood. Okay, so let's proceed forward. Now this is called humidity sensor. Now you might have seen nowadays we say in our smart home, you might have heard the concept of smart home. Yes or no? So in the case of smart home, you might have heard the ads also in the TV and all. While you are watching movie and all, you will see there is an ad saying smart AC. Have you heard the term smart AC? I'm sure you might have heard. Okay, now what this smart AC term means? So actually inside this smart AC, this sensor is actually implemented. Okay. Now what this sensor is doing? This sensor has two parameters. I mean, it can guess two things. One is it can tell you what is the humidity level, okay, and it can also tell you what is the temperature present inside the home, okay, which you can see here. Can you see that on this LCD? You can see the temperature is showing as 21.70 degrees Celsius and humidity level is showing as 55.40%. Okay, so what I am trying to make you understand here is that this sensor, okay, the name of the sensor is DHT11. This is the technical name of the sensor. So this sensor is also referred as temperature humidity sensor, okay, or generally we say humidity sensor. And these kind of sensors are implemented in the smart ACs. And this smart AC, what it does, it controls the temperature, it controls the humidity based on the value generated by this sensor. Okay, let's suppose if the temperature is generated by this is suppose 21 degrees Celsius, it means it is cold. Yes or no? So what will happen? The AC will be running at a very low value. Okay, a fan will be rotating at a very low value so that the temperature is maintained at 21 degrees Celsius. Okay, so with this sensor, what will happen? The AC will not be always working at the same value or same temperature as you have switched on. It will be actually taking the value of humidity and temperature from the sensor, and based on that it will decide whether it is actually required to switch on the AC or to run the AC at a lower value or to run the AC at a higher value. Let's suppose if the temperature is around, let's suppose 60 degrees Celsius. You are at your home, and when you switched on your AC, you found out the temperature is 60 degrees Celsius. The AC is checking itself that okay, the temperature is 60 degrees Celsius. What to do then? In that case, the smart AC will decide that as the temperature is very high, then it will run at a very higher speed. It will try to cool down the room very as fast as possible, and in that case you will see the value of temperature has reduced from 60 degree to 21 degrees Celsius. Okay, now once the temperature has reached to 21 degrees Celsius, then the AC will switch it off itself, okay, and will keep on checking the temperature only. Okay, and once again, suppose if the temperature is rising, let's suppose to 25 degrees Celsius, then maybe it will again switch it on for some time, and again it will reduce the temperature to 21 degrees Celsius, and again it will switch it off itself. Okay, so what benefit we are getting is that many of the time our AC is switched off, we are saving a lot of our power supply as well, and we are actually maintaining that room temperature also, and everything is going well. Okay, and a lot of things are saved. Okay, so that is the benefit of smart AC. Okay, so if you are interested in doing the project, you can connect this DHT11 sensor with your Arduino board, and you can run a program, and you can see the value of temperature and humidity on the screen. Okay, so this sensor is again very important, and generally it is used in the smart home applications or smart office applications. It is also used in industries also, where you have to maintain the temperature and humidity levels inside the room or inside some instrument or wherever. Okay, so generally it is used at many places. Okay, but the one which is in front of you, which you are seeing in front of you, this is generally used for the academic purpose. Okay, it is not directly, this one you cannot use in the companies and all. A better version, and you can say better quality sensor of temperature and humidity is available. Okay, so that is used in the industries, but this one which you are seeing here, which is actually named as DHT11, this one is used by the academic purpose. Okay, so we'll see how we are able to run this. Okay, so now let's proceed forward. Now there is separately one more sensor that is called as temperature sensor. So this is your separate sensor, which is a very low cost sensor. Okay, it is a very low cost sensor. Maybe this is costing around 500 rupees. So this one will be costing around maybe around 50 rupees or maybe around 60 rupees, not more than that. Okay, So you may feel that this is looking like a transistor, but actually this is not a transistor. It is actually the technical name of this sensor is LM35. If you can look carefully, if you can zoom your screen, you can see it is written there LM35. Clear to all of you? Okay. So this is the sensor which is used in the academic purpose. So if you are trying to use trying to capture temperature from somewhere for your project purpose, generally you will be using this one only. Okay, which is of low cost, and it is easily able to give you the temperature. Okay, and the technical name is what? LM35. You can even see here, guys. Let's zoom and see. Okay, so this is a very important sensor for you guys, and this also generates analog value only. Okay, what it generates is analog value. Okay, and this analog value will be again converted into digital value, and then based on that the temperature is calculated, and based on that the conditions and whatever is required is executed. Okay, and these are some temperature sensors which are used in industries. Okay, so RTD, thermocouple, thermistor, semiconductor based temperature sensor. So these are generally used in the industries, and they are very precisely giving the temperature value. Okay, so you should know that which one is used in industries, which one is used in projects purpose and all. Okay, so that it will be easy for you to purchase the academic level sensors and do your projects. Okay, so I hope you have understood this part also. Now let's try to move towards the next part, and let's see the application. I've just taken it from the internet and just want to show you that how nowadays people are using. So this is the you can say the industrial level implementation of the soil moisture sensor. So you can see here on the land, many places the soil moisture sensor is implemented. Okay, so and along with this the soil moisture sensor, it also have the Wi-Fi connection implemented in this. Okay, so all the soil moisture sensors are having the Wi-Fi channels available, and you can see all of them are connected to a Wi-Fi hotspot. You can see here, guys, at this place. Okay, a Wi-Fi hotspot, and they are sending all the data to this place. Okay, and from here the data goes to the server. Okay, and based on that the different analysis or different things are tested, and based on that sprinkler system or drone based things are sprayed on these lands. Okay, so generally if the area is very huge for cultivation purpose, then what we do, we implement these kind of sensors throughout the land, so that it can give us a aggregate, or you can say average value of temperature, moisture, everything from the soil, and then the decision can be taken whether the supply of water has to be given or a supply of something else has to be given. Okay, those things can be decided. Okay, similarly if you look here, you can see this person is trying to dip the soil moisture present in his hand inside the soil, and he is trying to see here what is the soil moisture content. Okay, so that also can be done. Clear? So let's suppose if you have only one soil moisture sensor, then instead of implementing it throughout the land, you can do what? You can take it and you can put it inside the soil at different places in your village, in your agriculture area, and based on that you can decide yourself that which area is having less water and which area is having more water. Okay, and based on that you can irrigate your land as well. Okay, so what I'm trying to show you here is that these are some practical implementations where soil moisture sensor, the temperature sensor, humidity sensor are implemented. Okay, it's already implemented. Okay, so if suppose you are trying for rooftop agriculture at your home, then you can implement this soil moisture sensor at your home only, and you can decide that at what time that the water flow should be given, or at what time the water flow should not be given. There is accurate amount of water present inside the soil. Okay, So those things can be decided. Okay. So I hope this basics is clear to all of you. Clear to all of you. I hope this part is clear to all of you. Now what we'll do, we'll move to Tinkercad and we will try to understand that if we have these sensors, then how we can implement it. Now on Tinkercad, there is one problem, that is we don't have those sensors available. Okay, means if I try to search for soil moisture sensor, then I will not get exactly the soil moisture sensor. Okay, or if I try to search for temperature sensor, then may or may not be we'll get the sensor which we are searching for. But one thing we know, that these sensors will be generating the analog value. Yes or no? We know that these sensors are generating what? The analog value. So if suppose you are your sensor is generating analog value, and you know that this analog value is the value on which you are going to decide everything, then what we can do is, instead of taking these sensors, we can take some device. Okay, we can take some device which is generating the analog value. Okay, and based on that analog value, we can do some work. Okay, we can perform some kind of action. Getting my point, guys? So I hope when I open up the Tinkercad, you don't directly start searching with the sensor, because that sensor is not available there. So instead of sensor, what we are doing, we are just trying to connect a device which is actually generating the analog value. Okay, and similarly, instead of connecting this sensor, as these sensors are also generating the analog value, so we will be having the analog value at last, and that was our ultimate aim. Okay, means if the moisture value is very less, the analog value will give me value nearer to 0. If the moisture content is very high, then we will be getting the analog value closer to 1000. Yes or no? So based on that, we will be doing the project. Okay, so for soil moisture sensor, I will be using a very specific device, and for temperature sensor, the LM35 is available. Okay, so that we will try to connect and see. Okay, so now let's try to move to Tinkercad. Okay, and this is the Tinkercad environment. You all are aware of Tinkercad environment. Okay, so we'll try to understand. Okay, so let's try to now. Already I have done a small project for you. I'll try to make you understand each and every pins connected here. I'll also try to make you understand the code required here. So listen very carefully, guys. Okay. So as I told you, this moisture sensor is generating the analog value. Then instead of connecting the moisture sensor, what I'm doing is I'm connecting this device. Okay. So what is this device? Even I have written here just to clarify everything. So you can see, instead of moisture sensor, what we are doing, we have, we have taken what? A potentiometer. Okay. So when you rotate the dial of the potentiometer, you look at this dial. Okay, this part, this is called dial. So when you rotate the dial of the potentiometer, what will happen? You will get values ranging from 0 to 1023. Okay, so this will be the range of the value. So what I have done is, to make it easy for you, I have just written some comments so that you can understand. So at one side of the dial, I have written here dry, and to other side I have written here wet. Okay, so when the dial will move from dry to wet, you can see that I'm getting a value which is very high. That ADC value is very high, and when we'll be moving to dry, you will see the ADC value is very less. Okay. Now based on that, what I'm trying to do is, I'm trying to switch on 2 LED bulbs. Okay. You all know that if you are able to control 2 LEDs, you can able to control 2 motors also. Okay. So just imagine that your motors are connected here, and based on the specific condition, I can switch on the motor and I can switch off the motor. Okay. So let's try to practically understand, and let's try to connect and see what kind of coding will be required here. Okay. So if you can observe carefully, and if I try to just zoom and show you for the connection part, then it will be easier for you to understand. So this is the potentiometer, and you can see I have connected the potentiometer's middle channel with A0. Okay, can you see that? And this part is connected with the ground part, and this red wire is connected to the channel number 7. Can you see that, guys? So generally, if you connect it to VCC, at that time what will happen, your potentiometer will be activated and will be working. Okay, but suppose if you want to control your control the ADC value generated by this potentiometer, then it is better to connect it to a channel. Okay, so if I'm connected, as you can see here, I've connected to channel number 7. Now at channel number 7, if I pass 5 volt, then this potentiometer will be activated. And if suppose I am passing 0 volt, then this potentiometer will be deactivated. I hope you're getting my point. Clear to all of you? So this part should be clear to everyone. Okay. So in this format I have taken so that I can control this potentiometer, and based on that I can also control when the temperature, when the moisture is getting collected and when the moisture is not getting collected. Those things we can take it out. Okay. So I hope the connection is simple and I hope you have understood. So along with this, what I have done, I have also taken 2 LEDs, and that connection you can see here. It's again very simple. Okay. If you look carefully, you will understand. Okay. So in this connection, you can see I have taken 2 LEDs. One LED is connected to channel number 8, and other LED is connected to channel number 9. Okay. And these 2 resistors which you are looking here, that is 220 ohm resistor. Okay. So I've taken one green LED and one I've taken as red LED. Okay. Now depending upon the program which you will write, you have to pass on the values. Okay. So let's try to now write the program, and let's try to understand how this thing will be perfectly executing and will give the correct result. Okay. So let me just zoom it out a little bit so that you can check it out easily. And let's now move to the coding section. So this is the coding section where we have written the code. Okay. And I hope you will understand. So listen very carefully, guys. So as you know, we have one LED present here, 2 LEDs present here, and one channel, that is channel number, if you can see carefully, channel number 7 also is taken as the output channel. Okay. So 7, 8, 9, these are 3 channels which we are taking as the output channel, and A0 we are taking as input channel. I hope this is clear to everyone. Okay. Unless and until this is clear, you cannot, if you even write down the program, you will not understand. Okay. So you should understand that how many channels are marked as output channel and how many channels are marked as input channel. That you have to understand. Okay. Clear to all of you? Okay. So with this, I hope you have understood all those channels which are marked as output channel and input channel, and that only we have written here. Okay. You all know that this function void setup actually execute only one time. So first of all, we are activating the serial communication by calling the function serial.begin, and we are passing the baud rate as 9600. And based on that, what we are doing is, in the void setup part, we are writing, or you can say we are describing all the channels. Okay. So as you can see here, channel number 7, 8, and 9, with the help of pin mode command, we are making those channel as output channel, and A0 we are marking as input channel. Okay, getting my point, guys? That is pin number 7, 8, and 9 is marked as output channel, and A0 is marked as input channel. Okay, clear to everyone? Now, once you have written the program till here, it means you have activated your channels by marking them as input and output. Okay. Now what we'll do, we'll try to run the program. Okay. We'll try to execute the program. We'll try to see how the output is coming here. Okay. So okay. So these 2 lines are actually not required here. I'll just delete from here. Okay. So what we are doing now, we are trying to, okay, before making you understand this, let me just open up the serial monitor. So this is the serial monitor. Okay. And accordingly, I'll just run the program and I'll show you the output first of all. Okay. And then if I make you understand the complete code, I hope you will understand. Okay. So let's start the simulation. The simulation has started. So you can see I'm getting the soil moisture value. Can you see that, guys? So here by default, I'm getting the ADC values as 205. Okay, and you can also observe that this red LED is on. Can you observe that? And the green LED is off. Okay, so what does it mean? I means we can get a meaning from it. Means the soil moisture sensor value is low, so it indicates it's by the red. It indicates it by red, means it is a dangerous time and you should start irrigating the land. Okay, clear? And when the soil moisture sensor value will be high, this green LED will be switched on, and it will make you understand that the moisture content is already present inside. No need to take any tension. Okay, that is the meaning coming out. Okay, so if you just observe carefully, what I'm going to do is now I'm going to move the knob of the potentiometer, and I'm going to increase the soil moisture content value. So suppose I'm moving it like this. So you can see now from 205, the soil moisture content value has become 389. Okay, now if I just move a little bit more, now can you see the value of soil moisture sensor is now implemented to 511 from 389. Yes or no? And if you still observe, the red LED is on and green LED is off. Okay, now suppose if I just move a little bit further, now you can see the value of soil moisture sensor has become 634. And can you now observe the LEDs? Guys, look at the LEDs. Now if you observe carefully, my green LED is on and the red LED is off. Okay, it means, what does it mean? It means that soil moisture content is okay and you don't have to take tension of irrigating the land. Okay, that can be the meaning. Clear, guys? Okay, now what does it mean now? That as your soil moisture content value will keep on increasing, your green LED will be switched on. You can keep any critical ADC value based on which you want to you want to start irrigation. You can do that also. It's up to you. Okay, and based on that, your LEDs will be switching on and off respectively. Okay, now let's try to understand the program. Okay, already we have understood void setup part. Now let's try to understand the void loop part. So in the void loop part, first of all, we have written serial.print. So this soil moisture equal to, which you can see here, soil moisture equal to, that is getting printed here. Okay, now what we are doing is we are writing digital write, and we are activating the channel number 7 by writing high. What does it mean? We are passing 5 volt. So to channel number 7, I am activating it as high. So what will happen? You can see this potentiometer is connected, the red wire is connected at channel number 7. So what I'm trying to say is that once you write digital write 7 comma high, what will happen? This device, though it is potentiometer here, suppose here we had the original sensor, then also we would have got the value, and you can say it will be activated by writing the digital write 7 high. Okay, so once it is written digital write 7 high, you can say this device will be activated. Okay, so once the device is activated, what will happen? It will grab the moisture content from the soil, and okay, and it will be displaying it on the serial monitor, as you can see here. Okay, so if you observe carefully, if I again rotate the pot value, you can see now from 700 the value has become 900. Yes or no? So that was the point I'm trying to show you. Okay, so now if you look, now move to the topic, to the code part. So first of all, we are activating the potentiometer, and that activation we are doing it for just 10 milliseconds. Okay, and in that time only we are reading the analog value generated by the potentiometer. Okay, and after reading the value, what we are doing, we are writing some if condition. Okay, so you know that once this analog read command is executed, what will happen? You will get the analog value. Okay, analog value, and based on that analog value, what we can do? We can write conditions. Okay, so if you look carefully, we have written some if conditions here, and the first condition says that if value is greater than 512, if the value is greater than 512, then the things connected at channel number 8 will be high, the things connected at channel number 9 will be low. Okay, So that's why you can see here the value is 921, okay, which is greater than 512. So channel number 8 should be high and channel number 9 should be low. So you can see at 8 green is LED is connected, so it is high, and this one is low. Okay. Similarly, you can write in the else part, okay, and later on you can provide the delay function so that you can get the desired output. Okay. So I hope everyone has understood how this moisture sensor is working and how we can practically show you here the way your sensor is working. Okay. I hope this much is clear to all of you. Now let's try to move to the next sensor and let's try to understand that part as well. So your next sensor is your temperature sensor. Okay. So that sensor also I have created here. So if you look carefully, you will understand. It's again very simple. So here we have taken that academic level sensor. If you remember, that was LM35. LM35. So this is a sensor which actually is used for academic level projects for generating the temperature value. So if I just zoom and show you, this is your temperature sensor, that is referred as TMP here. So TMP means temperature. So what I have done here is that I have connected 3 LEDs here and 1 temperature sensor. Okay, so already you know the connection, so I think it won't be difficult for you to understand. So this temperature sensor, if you look carefully, 2 wires, one of them is connected to the ground, other one is connected to the positive, and the middle one is going to the A0. Can you see that? The middle one, the green wire, is going to A0. Okay, so with this, I hope you have understood the simple connection. And LED connection already I have told you many times, and I hope you are able to understand here also. The only thing which you have to keep in mind is that the value of your every LED should be connected with 1 resistor, and generally the resistor value is 220 ohm. Okay, you should not keep it 10 kilo ohm and all. If you keep that much value, you will not get the desired output. Okay, so as I told you, this temperature sensor also works in the same way. So here the temperature sensor will also generate values ranging from 0 to 1023. But as you know that this is a temperature sensor, so what we will be doing is we will be converting this 0 to 1023 value to the respective temperature. Okay, so there is a functionality we'll see just now which can convert a range to other range. Means suppose I want to convert a value range which is ranging from 0 to 1023 to 0 to 10. Okay, means if I get 0, that is equivalent to 0, and if I get 1023, that is equivalent to 10. Are you getting my point, guys? Okay, so this is called equivalent scaling. Okay, so for that we have one function. We'll use that function, and with the help of that function, what we can do, we can find the equivalent temperature for the respective ADC value. Okay, for the respective ADC value, we'll get the respective temperature. Okay, and based on that temperature, I am activating and deactivating these LEDs. Okay, a very simple concept. I hope you have understood. So let's try to check it out how we can do it. So before checking the output, let me directly show you the running of the code so that you can understand. And when I'm making you understand the coding part, you can look carefully and you can guess and you can get the complete idea. Okay, so let's suppose I'm just started the sensor. Now if you just move to the temperature sensor, you can see if I just zoom and show you, it is showing me what is the temperature it is showing? It is showing 25 degrees Celsius. Okay, and if I just move it this side to the left corner, it is showing me what? Minus 40 degrees Celsius. And if I move to the corner, or if I move to the right hand side, it is showing me 125 degrees Celsius. Okay, so what I'm trying to say is that depending upon what temperature you want, based on that you can do lot of tasks. Okay, like suppose if I move to if I move to some place which is around 50 degrees Celsius, 56 degrees Celsius, can you see the green LED has been switched on? Okay, if I move a little bit more further, you can see all the three LEDs are on now. And if I go to the last, can you see all the three LEDs are blinking? Can you observe that, guys? I hope yes. So what you can do is, or what I'm trying to make you understand here is that depending upon the conditions which you want, okay, depending on the conditions which you want, you can rename or you can rewrite the complete project and get benefited. Okay, so now let's try to understand the coding section. Again, the coding is again very simple, though it looks a big code, but it is not big. It is very simple. So what I'm going to do, I'm taking the baseline temperature, something baseline kind of, where you can say this is the I mean, you can say average temperature kind of. Okay, and then I'm taking two more variables. One is named as Celsius, other is named as Fahrenheit. Okay, and I am sure you all guys might be knowing the conversion formula to convert Celsius to Fahrenheit and Fahrenheit to Celsius. Okay, that I'm leaving on you, and I hope you can do it yourself. Okay, now moving to the void setup. Now in the void setup, as you can see, I have taken I have marked A0 as input channel because there your temperature sensor is connected, and I have taken three more channels, that is channel number 2, 3 and 4 respectively, and I have marked them as output channel. Why I marked them as output channel? Because LED is connected there, yes or no? Now with this, and I have also activated my serial monitor so that if any output is generated, I can check it out. Okay, so with this, your void setup is done, and you might have understood which all channels are marked as output channel and which all channels are marked as input channel. Okay, so those things you have understood. Now let's directly move to the void loop part, and in this only you have to understand the important two lines. First two to three lines are very important. So first of all, you can see it is marked as the baseline temperature as 40 degrees Celsius. Okay, now as you know that we are making a very compatible kind of project which should be compatible to everyone. So maybe I mean the baseline temperature can be something to at some places. So what you can do is you can set this temperature as per the requirement. Okay, so here we have set the temperature as 40 degrees Celsius, and now if you look carefully, we have called a function called map. Can you see that, guys? And this map function, what it does actually, it helps you to convert the scaling. So if you remember, I was talking about scaling. So you can see in this map function, what we do, we first of all pass on the analog value which is getting generated. Okay, and then what we are doing is we are passing the values. Okay, the scale values. So both the scale values we already know. So you can see the second and the third parameter is the scale value of ADC. Okay, and the next two is the scale value of the sensor which you want to sense and set the value. Okay, so it's actually up to us what scale value you want to set. Generally people even don't set the scale value. Okay, but it's very advisable to set the scale value so that you should know the scaling factor. Okay, so here what actually is done, from 0 to 1023, the conversion is done from minus 40 degrees Celsius to what, to 125 degrees Celsius. So this is the scaling which has been done here. Okay, so this is done by the function map. Okay, so you can use the function map to convert from one scale to other scale. Okay, but make sure that you are passing all the desired parameters. Okay, so once you have done this much, let's proceed forward. So now once you've got the Celsius, you can get the Fahrenheit as well. Okay, and Fahrenheit formula you already know. Even if you look carefully here, you can understand, okay, there is the Fahrenheit value formula. Okay, so this will help us to get Celsius value also, Fahrenheit value also, and based on that we can write some if conditions. Okay, so you can see we have written how many if conditions. If you look carefully, can you tell me, guys, how many if conditions are there? 1, 2, 3, 4 and 5. Okay, so 5 if conditions are there. So it's up to you. Maybe somewhere it has been seen that people give only 2 if condition and then that also done. Okay, so it's up to you at how much if condition you want and what kind of output you want, what kind of logic I should implement. Those things I hope you can give a try. Okay, so what we will do, So we'll write the if condition and you see, we'll see how the output is coming here. So if you look carefully, in the first case, we have written Celsius is less than baseline temperature. Baseline temperature we have kept as 40. So if the temperature is less than 40, this condition will be true. And if this condition is true, what we have done, we have set all the three channel as low, low, low. Means if you look carefully, now if I see the temperature is the temperature is more than 40, yes or no? So as the temperature is more than 40, so what will happen? The condition will not be correct. So if I just try to run the program, maybe you will get a better answer. So let's try to run the program and see. So now you can see the temperature value is 25 degrees Celsius. So what we'll do, we'll try to increase the temperature and we'll move nearer to baseline, which is 40 degrees Celsius. See, I came to 41. Now, as soon as I came to 41, what happened? The first condition is now false. We're talking about the second condition. Okay, and second condition says that the Celsius value should be greater than baseline value. Baseline value was what? 40, and it should be less than what? Less than baseline plus 30. Baseline is 40. 40 plus 30 is 70. Means it should be less than 70. Okay, so whichever type of condition you want, you can write here, and you will observe that based on the different temperatures, based on different conditions, your different LEDs will be switched on. As you can see here, I'm moving towards the higher temperature. Like you can see here, it is 67 degrees Celsius now, and my two LEDs are switched on. If I move further, you will see that all the three of them are blinking. So why I've given like this? Because this blinking shows that there might be some kind of danger. Okay, because you know that 1 to 25 degrees Celsius generally people don't do. Okay, so it might be some danger. So just to show danger, I have used this blinking pattern so that one can see carefully and take benefit out of it. Okay, so there can be further many more applications of this temperature sensor. Okay, and you can utilize also many anywhere. Okay, and you can run the programs and you can even get the output. Okay, so I hope everyone has understood this temperature sensor as well as soil moisture sensor. Okay, and you all know the application of this one can be smart AC. It can be used anywhere. I mean, wherever you're talking about temperature, it can be used, and you can apply and you can get the output. Okay, so I hope these two sensors are clearly understood by everyone. If yes, then okay. If there's any query, you can write in the chat box. And if there is no query, then we can wind up today's class. Thank you, everyone.